So if you have a solid and there's like a lot of atoms inside, some of them are charged if like they have a negative charge, but if there's a defect in it where that's removed and inside what's trapped is instead an electron, it can, because you need to keep the solid balanced. So when you lose a negative ion, what's left is an electron there, and that electron is as if it's trapped in a little box, and that's like a quantum dot. So it's like when you trap a quantum object inside a small object, inside a small box, it can only have discrete energy levels, and the transitions between those levels corresponds to light. That process causes the crystal to be colored because it's a coincidence that the energy scale of an electron trapped in a region of the size of an atom just happens by coincidence to be the scale of visible light, which is also the scale that the sun is producing. For a completely different reason, the temperature of the sun is producing light at a specific, because of its temperature, it's producing light at a specific wavelength. That wavelength corresponds to the same wavelength that an electron trapped in an atom, size of an atom, produces. And that's actually why we see the things the way we see it. So that if you didn't have that coincidence, the sun could have been much hotter, the surface of it. That means it would have a lot of UV light. And then if the sun had a lot of UV light, then our eyes can't see with chemistry. We can't have an electron just jump to a different level because the scale of energy that's coming from the sun is enough to break up atoms and make them charged. That's why we can see different colors, why we have paint, because molecules can have that transition that matches the light that comes from the sun. If it was much hotter, for example, if the sun was hotter, it would ionize the atmosphere and we would not see the sun. We would see instead the atmosphere absorbing the light from the sun, breaking apart. And when it comes back, we start to see the light. So we would actually not see a sun. If we had a thick atmosphere, it would protect us from the UV rays, but we would just see light like a bright atmosphere everywhere.